Hello friends, welcome to the session, that is chapter 2, power semiconductor devices with respect to thyristor only. I explained so many concepts in thyristor. In the previous session with respect to series and parallel connection of SCRs, we solved some problems also. That concept also I discussed. The another concept with respect to thyristor itself, that mainly concentrate commutation methods, that you concentrate on. What are the different commutation methods we are using for commutation of thyristor? Yes, this concept is commutation methods. Commutation methods. Yes, concentrate, no doubt. Commutation methods. Yes. Tell me, what is the commutation? I given what exactly commutation in the explanation of turn-off characteristics of thyristor. What do you mean by commutation? The process of turn-off of thyristor is called commutation. The process of turn-off of thyristor is called commutation. Now, based on the type of process we are using, the commutation methods are broadly classified into different types. But once I am explaining the commutation means, once we are using the commutation means, the device is thyristor. We are studying the commutation. In any circuit, we are using the commutation means the device must be a thyristor. Then only it required to use the commutation methods. If it is a BJT or MOSFET or IGBT, no need of any commutation, because those devices are fully controlled devices. If it is a diode, even turn off is also not in our hand. That's why the diode is an uncontrolled device. For which device mainly we are employing the commutation? Semi-controlled device we are employing the commutation. I told na, if it is a thyristor, it can be turned on by gate signal, but it cannot turn off by gate signal. Now to turn off that thyristor, we are using some commutation methods. That's why once I am explaining the commutation methods means the device in the circuit must be thyristor. Then only these methods are applicable. Here, commutation methods means device is thyristor. If it is a BJT or MOSFET or IGBT, no need of these methods. By using control signal itself, we can turn on and turn off. Once I am explaining commutation methods means the device used in the circuit must be thyristor. Yes. Once again, I am writing here. What do you mean by commutation? Parallelly, you note down. The process of turn off of thyristor is called commutation. Parallelly, note down. The process of turn off of thyristor. Turn off of thyristor. The process of turn off of thyristor is called commutation. Is called commutation. The process of turn off of thyristor is called commutation. Yes. Here we are using the process for turn off of thyristor. That process is nothing but a commutation. We can use a different process to turn off the thyristor. Based on the type of process we are using, the commutation methods are broadly classified into 3 types. Here I am giving a general classification. Based on the type of process we are using, the commutation methods are broadly classified into broadly classified into parallelly note down all of you. Concentrate. Broadly classified into, one is natural commutation, natural or line commutation or class F commutation. Natural or line commutation or class F commutation. Alternative names also important in some competitive point of view, like in IES or other any PSUs, state government sectors. Alternative names and applications also important. For GATE point of view, along with the concept, mainly numericals are important. That you will see later on. Okay. Natural or line commutation or class F commutation. Okay. Alternative names also you concentrate. Very important. The next one is forced commutation. Another one is load commutation or class A commutation or self commutation. Alternative names also you concentrate. Self commutation. This is the broad classification of commutation methods. These are broadly classified into 3 types. Natural commutation, forced commutation, load commutation. Okay. Now, I want to explain in detail about each commutation methods. But point to remember, because to reduce the burden on preparing of these commutation methods. Okay. In this session, I will explain in detail about natural commutation. For remaining commutation methods, just I will give some introduction and application only. Alternative names and applications only. But in detail about this forced commutation method, mainly forced commutation and load commutation methods, I will discuss in the discussion of Chopper's concept. In chapter 3, I will discuss Choppers. In Choppers, based on the type of commutation, the Choppers are classified into different types. Where I am explaining the types of Choppers based on commutation and the concept with respect to commutation, both are same. That means once we are preparing the types of Chopper based on commutation, that same preparation is enough for commutation methods also. That's why no need to prepare separately. Then this important, we can reduce the burden on preparing for competitive point out. Easily you can prepare. That's why what I am telling here, in this commutation session, commutation method session, in detail I will explain only natural commutation, line commutation, natural or line commutation. Remaining forced commutation and load commutation methods, just I will give some introduction. Introduction in the sense, alternative names and application for theory point of view. But in detail about this commutation methods, I will discuss in the discussion of Choppers based on types of commutation. Based on type of commutation, the Choppers are different types are there. In that, once we are studying the types of Choppers based on commutation means the concept is same for forced commutation and load commutation also. That you will see later. Understood? Why I am doing like this means to reduce the burden on the preparation only. Clear? Understood? That's why I am giving only in detail natural commutation. For this commutation, I will give only some introduction. Understood? First, we'll start with the natural or line commutation or class F commutation. Okay. Now, we'll see in detail about natural commutation or line commutation or class F commutation. Okay. Is clear? That you'll see. The first one is natural commutation or line commutation or class F commutation. Okay. Just I am given one name, natural commutation or line commutation. Natural commutation. Natural commutation or line commutation. Yes. To explain this method, let us consider one rectifier circuit. Still now I am not started the concept of rectifiers. Here I am taken this example only to explain the commutation methods only. To explain commutation methods only, I am taking this example. But still now I am not started the concept of rectifiers. That this is I0, this is R plus minus V0. Okay. Let the supply voltage is Vs. Then Vs equal to Vm sin omega t. Vs equal to Vm sin omega t. This is thyristor. Okay. We are giving the pure sinusoidal AC supply. Sinusoidal AC supply I am giving. Yes, parallel you note down these waveforms and circuit. Let the input is pure sinusoidal. This omega t axis. Let this is pi, 2 pi, 3 pi. Okay. I am explaining the concept for resistive load. Yes, parallelly you note down these waveforms also. Yes. Let the supply voltage is Vs. The instantaneous supply. The maximum value of supply is this is Vm. On this side you can take minus Vm. Okay. Let this is pi, 2 pi, 3 pi. Let this is I taken V0, I0 on the same axis. Okay. And this voltage across the thyristor wave. Let the firing angle is alpha. Let the firing angle is alpha. Still now I have not started rectifier concept. I explained only natural commutation. To explain this natural commutation, I taken this example only. Yes, concentrate. Tell. During positive half cycle. Tell. During positive half cycle. During positive half cycle. During positive half cycle. Let for understanding. Let this is positive and this is negative. With this polarity, positive is connected to anode of thyristor. This is cathode. With this polarity, thyristor is under forward blocking mode. Still it is not conducting. Thyristor is under forward blocking mode. When the thyristor starts the conduction, whenever triggering pulse is given, then only thyristor starts the conduction. Yes. Let at omega t equal to alpha. Even we can trigger at omega t equal to 0 also. You can take at angle 0 also you can take. But for analysis purpose, let assume that I am not triggering the thyristor at omega t equal to 0. I trigger the thyristor. We are giving the triggering pulse at omega t equal to alpha. That means up to alpha, up to omega t equal to alpha, this thyristor is not conducting. When the thyristor is not conducting means, then it acts as an open circuit. Once it acts as an open circuit means the source is not connected to the load. Then up to alpha, what is the output voltage? 0. Output voltage equal to 0. Now, at omega t equal to alpha, we are giving the triggering pulse to the thyristor. When the triggering pulse is given to the thyristor, then the thyristor starts the conduction like this. Thyristor acts as a closed switch, then thyristor starts the conduction. This is V0 and this is Vs. If you apply KVL for this loop, then what you get? V0 equal to Vs. What is Vs? Vm sin omega t. Then output voltage equal to Vm sin omega t. Then whatever the input voltage is there, that voltage will appear across the thyristor. Up to what period it will conduct? First it will conduct up to pi. In detail about this discussion I will explain even in the rectifiers also. But this concept you concentrate how the thyristor is turned on. Don't concentrate on what is the output voltage, what is the output, RMS out, like that you don't concentrate. You concentrate in this concept how the thyristor is going to be turned on. Because it is a commutation method. Yes. V0 equal to Vm sin omega t. Then output voltage is equal to input voltage. This voltage will appear across the. Yes. At omega t equal to pi, then pi plus the input voltage is goes to negative half cycle. That means whenever negative half cycle is started, this is negative and this is positive. Because of this, that means now the question is during negative half cycle, what happening? During negative half cycle. During negative half cycle. During negative half cycle. Now what happening? Whenever negative half cycle is started, then because of anode is connected to negative plate, then thyristor is under reverse blocking mode. It comes into reverse blocking. Once thyristor is under reverse blocking mode, you don't apply triggering pulse. I told already. If any triggering pulse is applied to the thyristor under reverse blocking mode, is the thyristor start the conduction? Is the SCR will trigger? No, thyristor will not trigger. What happened? You tell me. Leakage current will be increased. That's why don't give triggering pulse under what condition? Reverse block condition. That means under reverse blocking mode, thyristor is not triggered, then it acts as a open switch. Thyristor acts as a open switch. Once the thyristor acts as a open switch, is there any input is connected to the load? No. Then output voltage equal to 0. Then output current is also 0. Again, at 2 pi, again positive half cycle is started. Okay. But I am not giving triggering pulse at 2 pi. For analysis purpose, we are giving the triggering pulse at 2 pi plus alpha. Once again, then cycle will be repeated. Mainly in the explanation of this concept, mainly concentrate on one cycle. For next cycle again, the process will be repeated. Again at 2 pi plus alpha, thyristor is triggered. Output voltage equal to input voltage. Here thyristor is conducting. Here also thyristor is conducting. Okay. Then this is V0. Then what is I0? You tell me. I0 equal to V0 by R. Then what we get? Vm sin omega t by Then that's the reason why I'm not drawing the waveforms V0 and I0 separately. The reason is I'm not concentrate on amplitude. I'm not concentrate on magnitude. You concentrate on wave shape. For resistive load, voltage and current waveforms are same. That's the reason why I'm not drawing separately. Because it is Vm sin omega t. It is also Vm sin omega t. By R means that amplitude will be changing. But you are not measuring the amplitude here. We are concentrating the wave shape. That's why for resistive load, voltage and current waveforms are same. Okay. This about V0 and I0 waveform. Now you draw the voltage across the thyristor waveform, you tell me. During positive half cycle, from 0 to alpha, this angle is alpha. This also alpha. And this also alpha. During positive half cycle, from 0 to alpha, thyristor is blocking or conducting? Blocking. Forward blocking or reverse blocking? Forward blocking. Forward blocking now. This spike is there now. This spike will appear here. Thyristor is under this voltage will appear here. Then at omega t equal to alpha, thyristor is triggered. Once the thyristor is triggered, it starts the conduction. Up to what period it is conducting? Pi. Then beyond pi, thyristor is forward bias or reverse bias? Reverse bias. Again it is blocking, forward blocking. Again it is conducting. Up to 3 pi it is conducting. Then what this voltage you tell me? Minus Vm. Reverse na? Minus Vm. Okay. This is waveforms. But here, not the, in these waveforms, all this not important here. How the thyristor is turned off? You concentrate, tell me. In this natural commutation or line commutation or class F commutation, during positive half cycle, thyristor is conducting. Whenever negative half cycle is started, the thyristor is turned off. Again positive half cycle, thyristor is conducting. Whenever negative half cycle is started, again thyristor stops the conduction. That means, what do you mean by natural commutation or line commutation? Means, in natural commutation or line commutation, the supply voltage itself is used to turn off the thyristor. That's why it is a natural commutation. Are you using any external circuit here to turn off the thyristor? No. Just, we are giving the supply. Whenever negative half cycle is started, thyristor stops the conduction. Whenever positive half cycle is started, again we are giving triggering pulse, then thyristor is conducting. Then in general, what do you mean by natural commutation? Means the natural commutation or line commutation or class F commutation means the supply voltage itself is used to turn off the thyristor. That means in natural commutation or line commutation. That is that you concentrate. In natural or line commutation, that is in natural or line commutation, in natural or line commutation, line commutation, the supply voltage, the supply itself, the supply voltage itself is used to turn off the thyristor. To turn off the thyristor. The supply voltage itself is used to turn off the thyristor. That's why it is treated as a natural. We are not using any external circuit. The supply voltage itself is used to turn off the thyristor. That means for every half cycle, supply voltage must be reversal, then only thyristor will be turned off. When it is happen? When it is possible, you tell me. If it is a AC supply, then only there is a possibility of, for every half cycle, the supply voltage is negative. That means for natural commutation, for existence of natural commutation, supply must be AC. For natural commutation, for natural commutation, for natural commutation, for natural commutation, supply must be AC. If it is AC, then only it is possible. If it is a DC supply, it is not possible. Supply must be AC. Then, in natural commutation, you tell me, what is the circuit turn off time here? How much time the circuit will be turned off? We know that it is the time taken a reverse voltage. What do you mean by circuit turn off time? It is the time taken a reverse voltage applied across the thyristor in one cycle. Okay, in one operation or in one cycle. You tell me. In one cycle, this is completed. One cycle is completed. How much time a reverse voltage is applied across the thyristor? This time only reverse voltage is applied now. Understood? Then, in natural commutation, the circuit turn off time equal to dash. What do you mean by circuit turn off time? It is the time taken. It is the time taken. It is the time taken. A reverse voltage applied across the thyristor. A reverse voltage applied across thyristor. Applied across thyristor in one cycle. Applied across thyristor. That is in one cycle. How much period it is applied? Omega t equal to pi. This time is taken as circuit turn on. Then circuit turn off time equal to pi by omega. Okay. This much of time a reverse voltage is applied across the thyristor. But don't think like it, sir. Here also thyristor is not conducting. But the definition of circuit turn off time is reverse voltage, not forward voltage. Then in one cycle, how much time reverse voltage is applied? Pi period. That's why circuit turn off time equal to pi by omega. Then what are the applications of natural commutation? Applications. Where you can use this natural commutation? Mainly concentrate on alternative names and applications. One is in rectifiers. Rectifiers we are using natural commutation. Then in AC voltage controllers. AC voltage controllers. Wherever the supply is AC, in that application we are using natural commutation. Even though in cycloconverters supply is AC, but in step down cycloconverter only natural commutation is used. Even though supply is AC in step up cycloconverter, we don't use natural commutation because for step up operation we must employ forced commutation. Then only step up operation is possible. That's why in step down cycloconverter only we can use natural commutation. Step down cycloconverters. In step down cycloconverters we can use. And line commutated inverters. In line commutated, not the normal inverter. In line commutated inverters only we can use. In line commutated inverters we can use the natural commutation. These are the different types of circuits we are using the natural commutation. This about natural commutation or line commutation or class F commutation. Mainly concentrate on alternative names and you remember these points. For natural commutation, supply must be AC. Wherever the supply is AC, in that application only natural commutation is possible. Understood? But here it is not inverter. It is line commutated inverter. What is line commutated inverter? Later on we will see. Okay, this about in detail about natural commutation. Then you go for forced commutation. What is the need of implementing forced commutation means? For example, instead of AC supply, if any DC is present here. Now this is the thyristor. Okay, let us assume that we are giving the triggering pulse to the thyristor. It starts the conduction. Once it starts the conduction, how this thyristor will be turned off? I told already. Don't allow continuous conduction. Once we are using any device in between load and source means the purpose of using semiconductor devices to control or convert. If you want to make control or convert the supply means always on and off is required. Okay, supply is DC. Then we are trigger the thyristor. Once the trigger thyristor starts the conduction. Then how this thyristor will be turned off? Is there any negative off cycle to turn off the thyristor if the supply is DC? Yes. No, there is no any negative off cycle. Eh? Now, in order to turn off this thyristor, we can use some external circuit. By using that external commutation circuit, then the thyristor will be turned off. That type of commutation is called forced commutation. That is the reason why we are implementing the forced commutation methods. Now we'll see concept forced commutation methods. What are the different forced commutation methods we are using? Second one is forced commutation. What do you mean by forced commutation means? This is the thyristor. Once we are studying the commutation means the device must be thyristor. If the supply is DC, there is some load is connected. Load is connected. Now, once the SCR is triggered, it starts the conduction. Then how the thyristor, once it starts the conduction, after some time you want to turn off this thyristor. Then how the thyristor will be turned off? Is it supply itself is turn off the thyristor? Is there any negative half cycle? No. Then to turn off this thyristor, we can use some external circuit. This is commutation circuit. This type of commutation is called forced commutation. That means if the thyristor is turned off by using external commutation circuit, then it is called forced commutation. That is, if the thyristor is turned off, if the thyristor is turned off, the thyristor is turned off by using external circuit, by using external commutation circuit, by using external commutation circuit, then it is called forced commutation. Forced commutation. Then it is called forced commutation. This is what exactly forced commutation. Then point to remember, this commutation circuit may consist of internal, it consists of L and C elements, and it consists of diodes, and it also consists of auxiliary thyristor, TA, auxiliary thyristors. It consists of L and C elements, or it consists of diodes. That depends. How many inductors, how many capacitors, how many auxiliary thyristors we are using, how many diodes we are using. That depends on the type of commutation we are using. Type of forced commutation we are using. That depends on type of circuit we are using. But in general, it consists of inductors and capacitors. These are called commutating inductor and commutating capacitor. It also consists of diodes. It also consists of auxiliary thyristors. In some commutation circuit, it also consists of transformers. Understood? That depends on the type of commutation circuit we are employing. Understood? Mainly this commutation circuit internally this consists. Then these elements are called, these L and C elements or diodes, all these are called commutating elements. Whatever the circuit consists, that elements are called commutating elements. TA stands for auxiliary thyristor. This is diodes. This is auxiliary thyristor. Auxiliary thyristor. This auxiliary thyristor. Like this it consists. Now, if the thyristor is turned off by using external commutation circuit, then it is called forced commutation. Then based on type of commutation circuit we are using, that is forced commutation methods are broadly classified into. But point to remember, forced commutation is applied or forced commutation is employed. Forced commutation is employed. Forced commutation is employed both AC and DC supply. AC and DC. If the supply is AC or if the supply is DC, we can apply the forced commutation. One of the example is if the supply is AC, that is step up cycloconverter, it is required to turn off the thyristor before completing one half cycle. Before completing one half cycle, if you want to turn off the thyristor, means compulsory you can apply forced commutation. That's why both AC and DC apply. Then types of forced commutation. Types of forced commutation. Here in detail I am not explaining, just alternative names and application only I will give, that I told already. In detail that I will explain in the Chopper's concept. Types of forced commutation. Then based on the type of circuit we are using, the forced commutation methods are classified into. One is that is class B or current commutation, or resonant pulse commutation. Class B or current commutation or resonant pulse commutation. Then what is the application of this? Application. One is current commutated chopper. Another one is Morgan chopper. This is one forced commutation. The next one is class C or complementary commutation. Class C or complementary commutation. Yes. What is the application of this? Where we can use this? What is the application of this? Parallel inverter. In parallel inverter we can apply this one. Parallel inverter. The another forced commutation method is concentrate. Third one is class D. Parallel, you know down. Class D. Class D or voltage commutation. Or impulse commutation. Voltage commutation or impulse commutation. Then what is the application of this concentrate? Important. Alternative names important and applications also important. Where you can apply? One is voltage commutated chopper. Another one is Jones chopper. The next one is class E or external pulse commutation. These are the different commutation methods we are using. Voltage commutated chopper, Jones chopper. The next one is class E or external pulse commutation. Here we don't have any application, that we will see later. Okay, class E or external pulse commutation. All these commutation methods are which one? Forced commutation methods. All these are forced commutation methods. But you concentrate. Type of commutation, application. Class B, application. Class C, application. Class C are complementary commutation, that is application, parallel inverter. Okay. Class D are voltage commutation or impulse commutation, application. That is voltage commutated chopper, or in Jones chopper we can use. Class C are external pulse commutation. Class C are external pulse commutation. Alternative names also you concentrate. Yes. This about forced commutation method. Then last one is you concentrate load commutation or class A commutation. Okay. Load commutation or class A commutation. Okay. Load commutation or class A commutation. Here also I am giving introduction. In detail later on. Load commutation or class A commutation. Class A commutation. Class A commutation. The load commutation or class A commutation. For load commutation, what do you mean by load commutation? Means by making load current is 0. By making load current is 0. Load current is 0. Thyristor is turn off. Thyristor is turn off. Then it is called load commutation. How we can make the load current is 0, that you will see in detail discussion of class A commutation. But point to remember, for load commutation, circuit must be underdamped. Circuit must be underdamped. Then only it is possible. We can design the circuit in such a way that it must be underdamped circuit. Then only load commutation is possible. That is, once we are talking about underdamped or overdamped or critically damped means it must be a, once we are defining the damping coefficient means it must be second order. It must be a second order means it must be one of the circuit is RLC circuit. That's why for load commutation circuit must be underdamped. Some circuit must be underdamped means that is condition is R square is less than 4L by C. This is the condition for underdamped circuit. R square is less than 4L by C, and we can select inductive and capacitive reactance in such a way that that is Xc greater than XL. Then only underdamped is possible. Xc greater than XL. Then what is the application of load commutation? Where we can use load commutation or class A commutation, or another name is self commutation. Where we can use these applications? The application of load commutation or class A commutation is we are using in series inverter. In series inverter we can use this commutation. This about different types of commutation methods we are using in the thyristors. In this concept in detail I explained only which commutation, line commutation, okay, that you seen by waveforms I explained. A remaining commutation method in forced commutation, class B commutation, class C commutation, class D commutation, class C commutation. That is B, C, D, E is forced commutation method. F is natural commutation. A is load commutation method. But by seeing this, even load commutation and forced commutation may be equal, may be same. That means load commutation also one of the forced commutation. But here the concept in forced commutation concept and load commutation concept is different. Okay, that's the reason why I am separating. Here no need to make underdamped all these. But if you want to employ the load commutation means you must frame the circuit must be underdamped. You can select R, L and C elements in such a way that R square is less than 4L by C. Then only load commutation. That's why I am giving separately. Forced commutation methods is one concept. Natural commutation method is one concept. And load commutation method is one concept. We can make the L and C elements in such a way that it must be underdamped circuit. Then only by making the load current is 0. If it is underdamped circuit means based on L and C elements at a particular instant current becomes 0. Once current is become 0, thyristor is also turned off. How it is? That you will see in this concept in detailed discussion later. Okay. With this, the commutation methods concepts, except in detail about forced commutation method and load commutation, that I will discuss in the choppers. Okay, clear? Thank you. Note down this. If anybody not note down, still no, note down this, and the next session I will continue.